So bachcho, welcome once again to TEJAS series. That's the second question again of a question of series. Again I will say it's a good question, it's quite a good question. Let's start. So see, what we have to evaluate? We have to evaluate this double summation with two variable a, b and a and b, of course. Okay, it's a and b. So ab over a plus b factorial. See, the problem here is the denominator a plus b factorial. Okay, here since a is independent, they are both independent one, isn't that? So a goes from 1 to infinity and b also goes from 1 to infinity. A and b are independent, but the problem is how will you take care of a plus b factorial? So that's the problem. Okay, so to take care of that, we can start. We can say, okay, let us start with a plus b is equal to p. Okay, how will it help? Because see, now our one variable will be p here and p factorial, and then you can take care of it. Okay, within factorial, if you have two different variables and you have to solve or simplify the factorial, whether it's series or it's anywhere else, it's really a difficult task. Okay, so that's the idea here. Replace a plus b by p. Now let's do it. So now we have to get rid of one of the variable because we have introduced one more variable, new variable as p. So let's say I will replace b in terms of a. Okay, so therefore capital P, whose value we need. So let's say then a goes from 1 to, see, the minimum value of b is 1. Okay, so the maximum value it can take is p minus 1, and then p goes from, because both start with 1, a and b, so the minimum value of p is 2 to infinity. Okay bachcho, so now it's a times p minus a over p factorial, and as I said here again, a and p are again two independent variables, so you can take p factorial out of it because it appears in the denominator as product, this thing into a goes from 1 to p minus 1, so it's pa minus a square. Now here again the variable for this summation is a. P is a constant for this summation, the first summation here. Okay, so now we know the values here, bachcho. So therefore I will write p is equal to summation. P goes from 2 to infinity and this is 1 upon p factorial. What do we get? So summation of a goes from 1 to n, or summation of r. Sum of r first n natural number is n into n plus 1 by 2. So here in place of n we have p minus 1. Okay, so p into n, p minus 1 into n plus 1. So again p by 2 minus summation of a square. Again instead of n we have to put p minus 1. So n, which is p minus 1 into n plus 1, p into 2p minus 1, because you have 2p plus 1 by 6. Replace 2n plus 1. Replace n by p minus 1, you will get 2p minus 1, isn't that? Now we have to just simplify and we got the entire series in terms of p only. Now then we will think how to do it. Okay, first let us simplify. So we can take p and p minus 1 common. P into p minus 1 is common, so we are left with p by 2 minus 2p minus 1 by 6 here. Now take LCM bachcho. Acha, meanwhile we can say, we cancel it, so we get p minus 1 factorial, and then we cancel it, we get p minus 2 factorial. So let's keep simplifying also, isn't that? 2 to infinity, 1 upon p minus 2 factorial. Now what? So let's take LCM. So this is 3p minus 2p is p, and then it's 1 upon 6. That's it. Okay, so now the question at last, where are we stuck, or where have we reached? We reached to the point where it's simply p plus 1. So 1 by 6, of course we can take out of it. P plus 1 upon p minus 2 factorial. Now still it involves few good things, like see which series will help us. So we get it. So if I write, we add 2, we subtract 2. Okay, so I'll be writing it as p minus 2 upon p minus 2 factorial, one thing, and then it's 3 upon p minus 2 factorial. Okay, so it's 1 by 6 times summation 1 upon p minus 3 factorial, p is equal to 2 to infinity, and then this is 3 by 6 is half times summation 1 upon p minus 2 factorial, p goes from 2 to infinity. Which series will help us? So exponential series is going to help us. We should know that e raised to the power t is 1 plus t square by 2 factorial, t cube by 3 factorial, t raised to power 4 by 4 factorial, and if I replace here t by 1, so we get e is equal to 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, and that's how it looks like. Start, like let's say if I start from here, so 1 by 0 factorial, which is 1, plus 1 by 1 factorial, which you already have, plus 1 by 2 factorial, so that's e. Okay, so what do we get here? So this implies p is 1 by 6 into. Okay, so put p is equal to 2. So here my negative factorial, we have to ignore it, bachon. Okay, we have to ignore it. So I will say p will start with 3 in this case. Okay, so this is e, and then this is again e by 2. So 4e by 6, which is 2e by 3. So according to me, that should be the answer for that series here. Okay, so as I said in the beginning itself, those were two very good questions of series. I hope this will help you a lot in solving further good questions related to series, bachon.